Hey everyone, thanks all for joining the Apache Pinot meetup. We have some special guests today, Elon and Jackie. Jackie, you've probably seen him multiple times here presenting, and Elon is one of our new presenters, which we're really excited about. Today's topic, let me just make sure that we're on mute here. So today's topic is going to be about the Trino connector for Apache Pinot. So first we're going to have, we have two topics today. We have the Pinot Trino connector, and then we have the gRPC streaming server for large-scale selection queries, which is a lightning talk that Jack is going to give after the Pinot Trino connector talk that Elon is doing. If you have any questions, feel free to put it in the chat right into the YouTube. We will have some people here from the StarTree and Pinot communities that can probably answer some questions, but we also do a Q&A at the end of Elon's presentation and also at the end of Jackie's presentation. And also, if you like it, like and subscribe, and make sure you give us some stars on GitHub too if you like the Apache Pinot project. And yeah, I think we can get started. Jackie, I'm going to put you backstage for a moment. I'm going to introduce Elon. We could start with Elon's presentation. All right, so I'm still getting the hang of this StreamYard thing, you know? I like it though. All right, so Elon comes to us. He's gonna do a presentation on the usage and features of the Pinot Trino connector. Elon is a software engineer at a stealth startup. Before that, he was a software engineer at Facebook on the Presto team. And prior to this, he was a DBA / software engineer in New York. Originally, Elon is from New Jersey. He moved to New York and then finally California. And in his free time, he enjoys bike riding, going to the beach, and playing classical and surf guitar. So Elon, I'll let you take it away. And here, we're going to add your presentation in. I'll let you take it away. And feel free to ask any questions in the chat. We'll be here and we'll see you after the presentation.
Sounds good. Right. Hello, everyone. So I implemented the Trino Pinot connector with help from the great Trino and Pinot communities. It seemed like a really good match. Both Trino and Pinot rhyme, and then Starburst and StarTree are very similar. So I'm going to start with just a very brief overview of Pinot and Trino architecture, just so everyone has context. Really quick, the Pinot has a few components. There's the controller, which is for admin purposes, like uploading segments or seeing, like the UI to see the tenants and status. The brokers are where clients issue requests, and they're spread amongst the servers, which store the data. And then the Zookeeper is used to store metadata, like the segment location, what tables have what segments, and so on. And then Trino, this is a simplified view of the architecture. There's the coordinator, which is the query endpoint, and also the endpoint for an admin UI. And then Trino distributes the query amongst the workers and processes it in parallel. And Trino has multiple connectors. It's a query engine. So this one is describing the connector to Pinot, which I will now get into. So we're going to start just with a simple query. This is just a select from a Pinot table called baseball stats that I think you're all familiar with. And this is just going to have a select, a filter, and a limit. So this is an overview of the workflow. The first step is that Trino will get the metadata, like what columns and what the table is and the schema of the table. Then it will parse the query, and then right before it emits the request, it'll get a list of the segments from Pinot, which is also acquired from the metadata. And then it'll evenly divide up the list of segments to each server and issue parallel server requests so that each unit of work is done in parallel. Trino has a unit of work called a split, which in this case is just a list of segments that are put into a server request, and each unit comes back, they're processed in parallel, and then they get merged, and then the Trino coordinator will send the results back to the client. So then let's get back to this table. So the first step, the Trino coordinator will reach out to the Pinot controller to find out the columns, the types from the baseball stats table. And then we will go to the second part where the Trino connector actually applies filter and limit push down in this case, because there's a filter and limit. I try to color code them so you can see them more easily. This will actually greatly reduce the amount of data that's scanned in Pinot, because the server requests will contain the filter, and then the limit push down is applied after that where possible. In this case, since it's a simple query, Trino will push down the limit so you only get 25K rows from Pinot instead of selecting the whole table. So then this is a server query, which is different than a broker request. This is actually what the broker does, the first part of the request, where it will take the list of segments and then have the filter and limit applied, send requests in parallel to the servers, and then asynchronously process the results and send them back to the client. Now, let's say we add a group by to this query. You actually want to take advantage of Pinot's StarTree index, which is one of the main features, and we use it to great benefit. It makes a difference between the query taking minutes scanning all of the data versus milliseconds, because the aggregates are in the StarTree. So in this case, with the group by, the push down will actually look like this. This is a new feature, aggregation push down, which we added, and it's in open source. So what this will do is actually change the query. Now it's no longer a server query. It's going to be a broker request, which goes to the Pinot broker, and the broker will properly use the StarTree index. What this does is just build the query so that there's a group by, and then change the request type from multiple server requests to a single broker request. And then just to give a little context there, so this will be a single Trino worker, so multiple of these broker requests can happen in parallel in Trino, and also in Pinot you have multiple workers and multiple brokers. It's a similar steps, except you get the segments and just issue a single broker request. So then there's a new type of query that we also implemented in the Trino connector to allow full push down. So if there's UDFs that aren't present in Trino, but they're present in Pinot, or you have certain aggregate functions like percentile, EST, which are specific to Pinot, you can actually put them in this, what's called a pass-through query, where you see the double quotes. That's actually a Pinot query. And part of the difference in the workflow there is that the connector will parse that query, get the metadata as it did from a regular query, and issue a single broker request. This is an overview of what happens there. So similar to before, first you get the metadata, get the columns from the baseball stats table, and get the list of segments, but this time only a single worker will send a broker request to a single Pinot broker, which then issues multiple server requests, just like any regular broker request in Pinot, and does the aggregations, takes advantage of all the StarTree indexes, inverted indexes, and Bloom filters that Pinot has to offer. So the first, just to go into details about that, the first step is getting the metadata. So the connector will take that query, the select team, comma, count star, etc., and parse it, find out that the table name is baseball stats, and the select list contains one column, team, and then an aggregate column, count star. Then it will get all the segments from the baseball stats table from the Pinot controller and issue the single broker request. And so I just want to describe some of the ongoing and future work. Aggregation pushdown is already submitted as a all of these are actually submitted as pull requests to the Trino connector, and we use them where I work as well. And it's been in use in production now for almost half a year, where we have aggregation pushed down that is almost ready to be merged. Right now it supports simple aggregations like sum, average, min, max, count, star, and also percent distinct count HLL, which is much faster than distinct count because you can leverage the StarTree index. In Trino, that will be represented by the approximate distinct count UDF. We also have a pull request for inserts, which I'll go into a little bit more detail, where you can actually, instead of having a Flink job like we initially did or a Spark job, data engineers can just say insert into Pinot where, whatever the data is that they have, and it will turn into an offline segment upload, which will upload the segments to the server. There's also a pull request to delete segments. This way, if you want, there's two options with insert. You can either add segments or replace existing segments if you have a specific date and you want to reconcile, like, Lambda architecture. So if you don't want to do that and you want to just add segments explicitly, you can also delete the segments using the segment name column to replace them. And another pull request we have that we actually use is to create, alter, or drop a Pinot table via Trino. This way we can control which data engineers have access, and it's a little bit easier for data engineers. They have one environment where they can work with all the different tables that they work with. So just to go back and describe some of the pushdowns. So this pass-through query, which is the query as a table as a query, the thing in between the double quotes, will actually support additional filters. So if you had a table that used some custom UDFs and things, you can put that in the double quotes, and then if you want to add a filter, create a view on it and have users specify a filter. This conference equals America East will actually be pushed into the double quoted query. So the Pinot will actually have that filter when the broker request is issued. And that really helps with performance and reducing the amount of data that's scanned. Aggregation pushdown is the newest feature that we added. This will automatically convert any query into a broker-only query, since that's what Pinot, that's the best way to take advantage of the StarTree indexes and all the other performance improvements that Pinot has to offer. And as I mentioned before, these are the currently supported aggregations. So if you issued a regular query like the one in the previous slide where you have select team count star like this, and then you had a broker query where there was no aggregation, the connector is smart enough to actually push all of that into Pinot so that you can leverage the StarTree index and get the results in milliseconds. For insert into Pinot, this is also a feature we've used in production. It's currently a pull request for the Trino connector. And what this does is it will bucket the rows and sort them, partition them by the time column. And that way each segment will have the rows partitioned to a particular worker. That will create the offline segment for the time column and push them to the Pinot controller, the upload download segment API. And you can actually have any query that has multiple segments, and it'll properly partition them to different workers to parallelize the uploading of segments. This way you don't have to just do like one partition at a time, for example. And this has made life a lot easier for data engineers, where now if they want to reconcile or backfill a table, they could just issue a series of insert statements instead of writing Flink or Spark jobs, which they may not be as familiar with. And then here's some resources. So the first two, you can run Pinot in Kubernetes and Trino in Kubernetes to try this out. The charts are both open source. And then here are the resources for StarTree, their new great website, and the Apache Pinot project, Pinot on GitHub, and Slack. You can always reach out to me on either the Pinot Slack or the Trino Slack, or directly in email. There's a Starburst website. They're the vendor that supports and develops Trino. The founders have moved to Starburst, so it's the innovations there are also great. And there's the Trino GitHub and Trino Slack projects. And if you ever have any questions, please always feel free to reach out to me, and I'll help you on either Slack, or you can reach out to me in my email. And thank you for listening, and thanks to both communities. They've been such a great help. Without them, I wouldn't have been able to implement this, and it's made life a lot better at our company, and the data engineers also. Thank you too. Does anyone have any questions?
Oh my God, I'm the one who's muted. All right, so I'm sorry about that. I didn't realize I had taken my headphones out. I was like, I thought it was me. Okay, sorry about that, guys. All right, so Elon, thank you so much for taking the time and doing this. This is great.
Sure, my pleasure.
So there looks like the chat is pretty active. But it looks like Mayank was in here, and Jackie kind of answering a bunch of questions. But if you want, you can kind of go through them and kind of dig into anything if you see anything that's really interesting. So do you want me to read them to you?
Sure. I actually see Pedro Silva asked some interesting questions.
Mm-hmm.
I can answer a few of these. So for
you probably should want to repeat the question out loud, just because if other viewers are.
So the question is, why not use pass-through for all Pinot queries? Is the Trino connector able to optimize certain queries that Pinot cannot on its own? There may be times where you want to just, if you have a simple select with a large number of rows, you may not want to go through the broker. We actually use both the direct broker queries for some real-time applications. So it may be more efficient sometimes just to get the data from Pinot. Other instances are where you don't want that, real-time response from the broker, and you want a large amount of rows. You can actually do something like a select distinct, for example, and it'll give you the distinct rows, and then Trino can do the distinct count, for example, on multiple workers, while real-time analytic applications can hit the Pinot brokers and not use resources there. So there are some instances where you may want to use just the regular, not use the pass-through queries. Although you can combine pass-through with regular queries, and it'll push down aggregations, filters, and limits where it's applicable. And then let's see, the next question. Pedro also asked a question about insert for real-time tables. So we actually have a pull request open in Trino for insert into Kafka, which can kind of emulate that behavior. where you insert the rows via Trino, and then they'll just come into the real-time table in Pinot. Let's see. I hope I'm pronouncing the name correctly. Jiraj Pohanka asked about select distinct. So distinct is enabled even in a regular query with this aggregation pull request, and it's definitely enabled in pass-through query where you just put it in the quotes like select distinct, team player, for example, and it will give you the distinct rows. If you do this in Trino, you can do select distinct count, and what it'll do is do the select distinct in Pinot, give you back all the distinct rows, and then Trino will do the count on top of that. Or you can do the select distinct count HLL, which is pushed down to Trino via the similar approximate distinct count function. That's actually much faster than doing a distinct count because it uses the StarTree index. So, that actually makes the difference between taking a minute or two versus taking 20 milliseconds on some of our larger tables. Let's see, Jiraj, I hope again I'm pronouncing it correctly. Will more complex expressions like ratios of sums or column aliases be supported in the pass-through query? Good question. We actually have an effort to support column aliases, and anything that's a valid Pinot expression should be available in the pass-through query. And if you run into any issues, please just post in the Slack, and I'll work with you to update it or review a change if you have one. We're always welcome improvements because that helps us too. So let's see. Another advantage of using Trino is that you can actually join with other tables. Pinot is specialized to be the fastest single table engine, which we've seen and used to great effect. But let's say you want to take those results and join them with other tables. That's where the Trino connector can also be useful. Let's see what other questions I can answer here. The timeline for the connector. So actually it's almost a no-op upgrade. I have it locally. 7.1 just works with the connector, and as soon as these pull requests land, I'll create a pull request to update the libraries. It's going to be 0.71. And then as soon as 8 comes out, because we're all excited about that, it's going to be amazing. We'll upgrade to 8 and enhance the connector further with all the new features and release 8, like the Boolean, varchar, and other, timestamp types, all these features that our data engineers and analytics teams are super excited about. So yeah, the second 8 comes out, we'll be working on that. Let's see. Are there any questions? I hope I answered all the questions. Feel free to ask more.
There's some good questions coming in.
Yeah.
Yeah, this is so there is a little bit of a delay between the video and the live stream. So it's something like 15 seconds or something. So if anybody sees this now, please write your question as soon as possible. So, we can answer it while we still have Elon here. But Elon is also very active in the Pinot Slack, as he kind of mentioned. So if you want to jump in there too, if you see this too late and you have additional questions, feel free to ping him there. This was really cool, Elon. Thank you so much for taking the time and working on this, because this is awesome.
Yeah, I love it. And thanks to the Pinot community for being such a great community. Everyone's so helpful and really appreciate it.
Especially you. You're also very, very helpful.
Thanks.
I do want to say, just to the attendees and viewers and stuff, one thing that's really nice is to give feedback to the presenters and the contributors, the committers and stuff like that. They really appreciate, people's feedback. So if you're using something and you find it very valuable, or you have any kind of thoughts or feedback for them, share it with them, because that does make a huge difference. If you're contributing to something and putting a lot of effort into it, and then you see people are using it, it's really cool. Right?
Yeah.
All right, cool. Elon, so I think we can wrap up now. I think the Q&A kind of went to quieter, even though it wouldn't surprise me if there's going to be a lot of coming questions in the next couple of months after this.
Yeah, of course.
On YouTube. So thank you so much for taking the time and like working on this. This is really awesome.
Yeah, thanks everyone.
A lot of perfect. Thank you so much for answering and working on this and my awesome presentation. Thanks again. All right, cool. So I will drop you now. Thank you, Elon. See you on the other side, on the Slack side.
Yep.
All right, cool. So our next presenter is Jiang. He's going to be presenting on the gRPC streaming server for large-scale selection queries. And I'll give a little intro into Jackie. So Jackie is actually, he's my colleague. So hold on one second. Sorry about that. We have a new bio for him. So Jackie is a founding engineer at StarTree. Before this, he worked at the LinkedIn Pinot team for more than 4 years and became the PPMC and one of the top contributors for Apache Pinot. Jackie's goal is, and I love this so much, is to make Apache Pinot the fastest online analytics platform on the market. So welcome, Jackie.
Hi everyone. Thanks, Karin, for the introduction.
Yeah, thanks for being here, and thanks for presenting every week, basically, for the next 3 months. Jackie has a lot of stuff to talk about. So, all right, I'll let you, I'm going to jump off. Afterwards, we'll also do a Q&A, but feel free to ask questions during the presentation as well, because there are also some of Jackie's colleagues and other PMCs and committers for the Pinot project here as well. All right, so I will jump off. See you soon.
Thanks, Karin. So hi everyone, I'm Jackie, and today I'm going to talk about have a lightning talk on the gRPC streaming server for large-scale table scan queries. So actually, this feature we built it for the Trino Connector and Presto Connector. So let's take a look now. So first, I'll give some example of the large-scale table scan queries. So first example is like a food table scan. For example, I just want to dump all the records from a table. And then the query is fairly simple. It's just select star from my table. And then the second example is there might be some like queries that scans table with relatively low selectivity filter. For example, I have a user table, and then I want to read the user info for all the users in US. In this case, the query will be something like select star from users, where country equals US. And then basically, let's assume like a big portion of the users are from US. So basically, this filter will have fairly low selectivity. So let's say, so Pinot is like really shining on like analytic queries like slice and dicing, aggregation, and group by. So when do we need to do this kind of large scale table scan? So actually, the answer is mostly from Pinot connectors. For example, like the Trino Connector, Presto Connector, when like users trying to leverage them to solve join queries on Pinot tables. So currently Pinot doesn't support join natively. So users usually can leverage the connector to do join queries. So let's take an example. For example, I want to calculate the total credit transaction amount from US customers. So one solution is I can pre-join the tables. But if the table is not pre-joined yet, the query will be like, I need to select the sum of amount from transactions table, and then from like transactions inner join with customer table on the customer ID key. And then the filter is transaction type equals credit, and then customer's country equals US. So on Pinot side, because Pinot doesn't support join, we need to do scan a fairly large amount of records from these two tables. So basically from Pinot side, we will get the first query is select all the customer ID and amount from transactions table, where type is credit. And then another query is I need to select all the IDs from customer table, where the customer has country equals US. Okay, so now on Pinot side, we need to solve these two queries. Basically, both of them has a low selectivity filter. And if like usually these transaction tables will be large, so then we need to end up scanning a lot of records. So let's first take a look at how Pinot handle the query. So on the query handling, on the query engine, basically there are two components involved, the Pinot broker and server. So first, Pinot broker receives the query, and then it calculates the routing table for the query, and then route the query to all the servers that holds the data for this table. And then server read the data, and then send the server response back to the broker. Then the last step is broker basically merge all the server responses and then return the final result. Okay, so now let's take a look at the problem of large-scale table scan. So Pinot, basically Pinot is all in memory, like basically data engine, query engine. So Pinot will hold all the whole query result in memory. And then for large scale table scan, because we need to like return, for example, millions of records as a result. So it can cause memory issues on first on the server side when we process the query and then calculate the server response. And then on the broker side, when the server responses are gathered, and also on the transport layer, where we need to transport the server responses to broker and also return the final result from broker to the client. So basically, all this like components and also like the transport will, it's basically like there are some like risk on memory. Yeah, basically like so basically everything can potentially break. So next, how can we solve this problem? So let's take a look at the gRPC streaming server. So first, what is gRPC? gRPC is a high-performance open-source universal RPC framework. It's quite popular. And then the gRPC streaming server is so basically we leverage this framework, and then we build the Pinot streaming server to avoid holding the whole query result in memory and then stream back the records by blocks, like instead of just gathering millions of records and then send them back as one response. So let's take a look at how it works. So here I have a gRPC streaming server, and I directly receive a query from the client. So the client could be broker, or it could be, for example, Trino or Presto worker. And then after receiving the query, it will calculate the selected records. So basically, the calculation here, it doesn't really fetch the actual records because that can cause that can cause memory issue as mentioned before. So here, actually, it only calculates the documents, and this if there's like index on top of this query, it can directly fetch the matching documents. Because now basically the filtering is applied while scanning, and then basically it won't load a large number of records in memory. And then when it responds, basically basically it keeps streaming back records while scanning and processing the records. And each time it will only stream back a block of 10,000 records. And it will keep scanning, streaming back records. And the last one, so we won't, so the last block, there will be less than 10K records. So it will just streaming back the last block, and then at the last, it will also return the last block as metadata block to mark, okay, the query is done processing, and then also it returns all the useful metadata info. So the gRPC streaming server solves the memory issue because the Pinot server only holds several blocks. The reason why it still holds several blocks instead of one block of records is because we do parallel query execution on multiple segments. So basically, we might hold one block of record per segment, but still, like, there will be only 10 or 20 blocks, which won't cause any memory issue. And then on the client side, for example, the Pinot broker or Trino Presto worker, it can process records block by block. So it won't cause problem on the broker side, client side as well. Then on the transport layer, because each time we only transport back one block of records, so it only needs to buffer several blocks of data, which is also fine because it won't buffer like megabytes or even hundreds of megabytes of data. So now let's take a look how can I enable the gRPC streaming server. It's fairly simple. So we just simply add the following two configs into the Pinot server config, and then it's ready to go. So basically enable the gRPC server and then give a port for it. Okay, so basically that's my lightning talk. And then the gRPC streaming server is available in Pinot version since 0.6. And also right now it's available in Presto Pinot streaming connector. Basically you only need to put this line of config into the Pinot catalog config, and then it automatically works. And then the Trino Pinot streaming connector is a work in progress, and then I think Elon is working on that. So please reach out to him to get the latest updates. Thanks. And then that's my presentation.
Awesome. Thanks, Jackie. I'm not on mute this time. Look at that. Okay, so we do have a question from Pedro. Pedro is asking a lot of really good questions today. Does the Trino connector use this gRPC service by default? I'll add, I can, well, Elon doesn't look like he's, okay.
Yeah, I can answer. So, or I think we should bring Elon back if
Elon is ready. He looks like he kind of might have stepped away from the stream, but I could ping him.
Yeah, but basically, yeah, I already answered the question in the last slide. So I think, as far as I know, Trino Pinot streaming connector is still work in progress. But for Presto Pinot connector, you can enable it by putting the config in the slides into the Pinot catalog config. Hi, Elon.
Hey, yeah, we actually have a POC that with this working, we just need to submit a PR, and also we're kind of playing with this in our like dev and staging environments too. But yeah, this is actually an amazing thing, and it'll allow people to do like huge queries on Pinot without killing the server. So we'll be getting that pushed soon.
Nice, that's awesome. If anybody else has any other questions, please ask now. You have, I don't know, 20 seconds before we jump off. Is there anything else that you guys want to fill people in about, like what's to come in the future or anything like that?
I mean, I just have ideas more about making alter, create, and drop table, delete segments easier, making the insert more efficient, and integrating the gRPC streaming, because that's going to be a big win.
That's awesome. That's really cool. All right, cool. So I guess if the questions are at a minimum now, I'm sure there'll be more that come up as people start playing with this stuff too. But you guys know, for all the viewers, you can definitely ask in the Slack. Jackie and Elon are both there very actively. So they're pretty easy to find there.
Jackie helped me a lot too. So.
Jackie did? Yeah. Hey, thank you guys so much. Really, this is awesome. Really appreciate you like taking the time out and contributing to it and taking the time to present on it, because that's also helpful too. Ken just asked a question/comment. Oh yeah, he said there are other situations where holding everything in memory creates issues. Example, we had a memory issue with brokers when we did a count distinct versus a distinct count HLL. Will gRPC help with this?
So actually, that's an issue that we experienced as well, which is why in the aggregation pushdown, I only implemented the distinct part and then let Trino do the, you get all the results, and the gRPC streaming will absolutely help with that, because the results will stream from Pinot to Trino, for example, and then Trino can do the distinct count. These are on slower queries. For distinct count HLL, that's pushed down when you do approximate distinct in Pinot, or if you just put it in the pass-through query in the double quotes. You can use percentile EST, distinct count HLL, any aggregation function that Pinot supports.
That's awesome.
Yeah,
cool.
on Pinot natively, right now we don't support like flashing the result onto disk like what Trino and Presto did. So for count distinct query, we still need to buffer everything inside memory. So I think in order to solve this, we can try to make the broker processing off heap. But this is like right now it's not supported yet, but we will work on this. Yeah.
Awesome. Cool. Thanks again, guys. This is awesome. We're going to have to schedule another one where every time you guys do some more cool, interesting updates in the projects. If you're okay with that, of course.
Yeah.
All right, cool. All right, thank you guys so much. And for all the viewers out there, please like the video, subscribe to the channel if you haven't already, join the Slack, so we can just continue the conversation there. All right, have a good day.
Bye, have a good day.
Bye.